So one interesting piece of evidence against man-made climate change is the data from rainfall, and this, if you can go look at this online if you want to. You can look at the rainfall statistics on Statista.org for the UK, and you can see that rainfall since 1910 hasn't really increased or decreased all that much. It stayed pretty much level, except for a very, very slight increase as you get into the 21st century. And this isn't really what we should be expecting from climate change. What we should be expecting more like is that if the planet's getting warmer, there should be more evaporation from the seas, there should be more rain clouds forming, hence there should be more rain. Um, and it's interesting also if you look at instances of flooding in the UK, and whenever we have big floods in the United Kingdom, everybody always points to climate change as the cause of these. But actually, the rainfall isn't all that much different to what it was in 1910. And the data's out there. You want to go look at it if you want. So this is something of a conspicuous problem. And if you look at also the theory about climate change and rainfall, it varies dramatically and it varies between different sources that you read. And you can look at NASA's websites, for instance. They talk about this, and they talk about rainfall decreasing as a result of climate change, supposedly. That, the more sunlight we get, the less rainfall there is somehow, even though there be more evaporation and so on, which doesn't really make a lot of sense. And this is what I was taught about climate change in school, that as the climate gets warmer, we'll be experiencing more droughts and so on. Then more recent research comes along, and this is all to do with the Clyde cloud climate feedback. And this is one of the most hotly disputed areas in climate change anyway, and it's kind of an open area of research, and no one's really come to any firm conclusions yet. And it's all kind of up in the air to do with how clouds are modeled in climate models and what have you. And yeah, some people say there'll be more rainfall, some people say there'll be less rainfall, but if you look at rainfall, it actually remains relatively constant, which seems to imply, I think, that the temperature hasn't really been increasing or decreasing at all, really. And if you look at the statistics on the world's average temperature from NASA and so on, they give the world's average temperature 15 degrees Celsius, whereas actually that would be 2 degrees hotter than the average temperature of the Sahara Desert, which is 13 degrees Celsius. And the reason they've arrived at this erroneous statistic is because they haven't taken into consideration that the Earth gets cooler at night. It's the NASA Terra mission, I think it that was originally put into space to measure the Earth's average temperature, among other things. And they're only measuring it during the daytime, which, I mean, is kind of slipshod, really. That's sort of a massive oversight if you think about it. That's a massive kind of, thing that I think is pretty worrying from NASA scientists. And we really ought to be doing better than that. We shouldn't be putting out statistics saying that the average temperature of the Earth is 15 degrees Celsius when it isn't. It's just untrue. That's the reason why I dislike it. And there's other reasons also for disbelieving the climate model actually come down to the nature of the greenhouse effect itself. And this is the classic model of the greenhouse effect. You have visible light hitting the Earth, gets converted to infrared, reflected again as infrared from the planet's surface, hits carbon dioxide in the atmosphere, gets reflected by the carbon dioxide back down again towards the atmosphere, and then we have this greenhouse effect. We have this infrared that's unable to escape from the planet, right? However, I think if you model carbon dioxide molecules in the atmosphere as static points, which you really shouldn't do, then you probably would come up with this understanding of the greenhouse effect. However, the carbon dioxide molecules are not static points at all. They whiz around very, very quickly in the atmosphere. All molecules of air whiz around very, very quickly, even nitrogen and O2 and everything else. That's all whizzing around at high speeds, changing directions, flipping over, and doing all sorts of things other than just staying still. They most certainly do not stay still, and are not static points. So We know from research actually from a paper put out by the Royal Society that's supposed to highlight the dangers of carbon dioxide in the atmosphere. They modelled it as a balloon filled with 100% carbon dioxide and had a heat source at the balloon's aperture entrance thing, and was trying to measure how quickly carbon dioxide loses heat. And it loses heat only very slightly less quickly, less quickly than air does. And this gives enough time, obviously, for the carbon dioxide molecule to flip in the atmosphere and emit the radiation back out into space. So really, there's only a 50-50 chance that infrared radiation coming from the planet's surface is going to be reflected back down again towards the planet's surface. Half the time it'll be going straight back out into space, and this is another oversight that I think climate scientists haven't really looked into and don't account for in their models, which would be severely offsetting the amount of global warming that's being caused by CO2 in the atmosphere. Then, of course, there's all the benefits potentially of CO2 in the atmosphere, such as it being plant food. And we know from yet more research that the Earth since 2000 has got 5% greener. 5% of the Earth's surface has become green. That's an area the size of the United States becoming greener as a result of conservation and agricultural interventions, but also as a result of us emitting CO2 into the atmosphere and feeding plants this way. The leaf area index of the Earth has actually increased in the period when we've had the greatest CO2 emissions. So that's yet again another reason for doubting that man-made climate change might be such a bad thing after all. And based on rainfall statistics, I'm really not certain that the temperature is increasing. And I don't see any error bars on these graphs for temperature increase globally. I don't see that. There must be like 1 or 2 degrees at least error in your calculations that you're not taking into consideration. Where are the error bars? And if there's no error bars on your graphs, why should I take it seriously? If you're not acknowledging that you could ever make a mistake at all, that your results could not reflect any degree of uncertainty whatsoever, then I shouldn't have to take it seriously. Then, because that's what good science does. It always presents its results in terms of, well, a likelihood of it being correct. They'll never say that this is 100% correct and that you can't question it, but that seems to be what fucking climate science does. And I think there are real problems facing the environment. I think there are real problems facing the planet's ecology and biodiversity, such as soil degradation, habitat loss, ocean acidification, and that there's all sorts of things we shouldn't be emitting into the environment. But I happen to think that I don't think CO2 is one of those. As sort of an ecologically minded person, I think I very much follow in the kind of the pathway set out by Patrick Moore, former head of Greenpeace, and various others who disbelieve the model of man-made climate change. And I'm very sorry for having to say that, but I think it's a huge distraction from much larger and more serious issues, particularly soil degradation. 1/3 of the planet's soils are either severely degraded or completely degraded, I think it is at the moment. And this could be set to increase to 95% by 2050, which really, if you think about it, given that we're in 2025 at the moment, isn't all that much time at all. And yeah, it's a very pressing issue. It can be reversed, however, in all sorts of ways. Careful land management, rewilding, regenerative agriculture, biodynamic systems, all these sorts of things. One excellent way of phytoremediating the soil is also to sponsor hemp agriculture. That would additionally lead to huge amounts of carbon sequestration also. But as it happens, I don't think that that's such a huge issue. Oh, and one more thing that I'd like to point out, that CO2 still is 0.04% of the atmosphere. So when it comes to this visible light entering, getting shifted to the infrared, then being emitted again, I think it's actually pretty unlikely that an infrared photon would encounter a CO2 molecule at all. So that like it would just go straight back out into space again. It's not certainly going to interact with a CO2 molecule, and that's going to offset yet more warming. And I think that, the rainfall statistics are a big clue in this. I think cloud climate feedback is nowhere near good enough science yet to be able to say for certain that it's causing either global warming or global cooling, i.e. the CO2 in the atmosphere. And I think that we need to take the planet's albedo into consideration when thinking about climate change and global warming and so on. And that, if the planet is warming up, there'll be more clouds getting formed. There'll be reflection of light, crucially, from those clouds back into space. And we wouldn't have global warming. But who knows? It might cause ocean acidification, I think, which might carry with it all sorts of attendant downsides. But then again, I look into things like the Great Barrier Reef, and apparently there's never been more life in it than at present. So I'm just thinking, like, is it really affecting biodiversity in the oceans all that much? I think overfishing might be affecting biodiversity in the oceans, but fishermen seem to have clued onto that in recent years and are altering their fishing practices so they don't overfish. And likewise, farmers on the land, are adapting their farming practices now, a lot of them, to account for things like soil degradation and erosion and compaction and salinization and all these things that negatively impact the soil, at least in this part of the world. It's very different in other parts of the world, but nonetheless, I think a lot of farmers are now starting to realize that putting huge amounts of chemical fertilizers on their fields and glyphosate and all the other pesticides, herbicides, fungicides, etc., really aren't very great for biodiversity and ecosystems, and that we rely on the soil for life as much as any other creature, and that we're just shooting ourselves in the feet if we continue these sorts of practices. So this is a bit of a rambling, incoherent video. I'm really sorry about it. It's gone on for too long at the moment. So I think that's roughly what I wanted to say about this. But yeah, I mean, all sorts of people have disagreed with the model of man-made climate change. I'm not the first one. There's the Nobel laureate John Clauser. There's the Wolf Prize winner and eminent mathematician Freeman Dyson, now deceased. He was a rogue thinker by the end of his career, doubting the model of man-made climate change, and rightly so. And I think it's based on poor science, poor modeling, bad assumptions, a conspicuous lack of nuance in terms of scientific understanding, and it's highly unsubtle, outdated, outmoded, bad science. And I think CO2 might actually be a pretty good thing for plant life. So that's what I've said. And there are far bigger dangers facing us as a species than climate change. There is, for one thing, the prospect of nuclear war as well, which we're also facing as a result of resource security issues. But that's a topic for another video. And a very scary thing it is, that prospect. But yeah, soil degradation is a huge, huge problem that needs addressing right now. And if we don't address it, we are going to starve ourselves to death and starve millions of the world's poorest people to death, if not billions of them. So yes, that's something which majorly needs addressing.